Okay, so we're going to try to do an exercise. See how it's raining outside? Look at the rain come down, okay? So as you can see, the pavement there is being pummeled by a Southern California winter storm that we hope will be coming Thursday. And I'd like to use some of our ideas about momentum to figure out what is the average force that the rain exerts on the ground, actually the average pressure, so the average force per unit area of the pavement out there. Now, it's true, 0 is the correct answer at the moment, but we're imagining that the rain is falling down, and I want to make an estimate of that pressure. What do I need to know to make an estimate of that pressure? Sure.
How much rain is going to be falling in a unit area? How many raindrops?
Okay, so we would like to know number of raindrops. What else? What else do we need to know? Yeah?
The volume per raindrop?
How about the volume of a raindrop? Volume of a drop. What else? What's the base principle that we're going to have to... Yeah, wave them back. How rapidly a raindrop is brought to rest. Stopping time? Yeah, so, okay. What else? Yeah. Terminal velocity of a raindrop. Why would that be important? Yeah, so what's the principle that we're going to apply in order to figure out this force or this pressure?
Change of momentum over change of time.
Yeah, so it's the force is the rate of change of momentum, and we have a bunch of raindrops coming down, each one carrying some momentum, and then what are we going to assume happens at the ground? I mean, there could be splashing and stuff, but let's just say they come to rest. All right? So if I want to know in a little bit of time, delta t, how much momentum is deposited on the ground from the following rain, I'm going to need to know, okay, how many raindrops arrive in that time, delta t? Is that right? And why do I care about the volume?
The mass.
Oh, to get the mass. Yeah? Okay, so density of H2O, which we happen to know? One. One what?
1 gram per centimeter.
Anything else? Anybody have a guess for terminal velocity? How fast does a raindrop fall? Less than the speed of light. Wrong. How about 1 meter per second? Is that too slow? 10 meters per second. 22 meters per second. I'll go with 10. It's easier for me. So terminal velocity, that's about 10 meters per second, I'm going to guess. Okay, what about, how big is a raindrop? Like a kilometer, or how much? Across? Yeah, so she says about 5 millimeters across. So that's... Yeah, a good raindrop. 2 millimeters? All right. So how about if radius of the drop is 2 millimeters? That's not so big. Is that all right? 2 millimeters? Okay. So I now want to get the mass of a drop. How do I do that? What's the volume?
Assuming that it's a perfect sphere.
Fine, assume it's an imperfect sphere, whatever that means. Okay, so r squared for the volume. Lash him with a wet noodle. 4/3 pi r cubed times rho will be the mass of a drop. We will, just a moment. All right, so pi is 3, because we're in the state of Kansas, and r cubed is 8. 8 times 4 is 32. See, that wasn't so hard. So we have 32 watts. So this was in millimeters, so that's millimeters cubed. But rho was 1 gram per cubic centimeter. So what does that mean in terms of grams? Right, so I want to get rid of millimeters, so that's in the bottom. 10 of those is equal to 1 centimeter, and I need that 3 times. So that looks to me like about that much?
Per raindrop.
Per raindrop.